Okay, hi kids. Now we will be going with some of these questions from optical instruments. All are from NCERT. So anyway, I'll be going in sequence. I'll be going with simple microscope, compound microscope and telescope. So let me look at this question. A card sheet divided into squares, each of size 1 millimeter square, is being viewed at a distance 9 centimeter through a magnifying glass of focal length 10 centimeter held close to the eye. What is the magnification produced by the lens? How much is the area of the square in virtual image? What is the angular so anyway, let us see like what they are talking about. So this is the figure. Now I will just mark the things what they have been given in the question. What they have given in the question. 1 minute. Yeah, so I will mark the questions which have been given in the question. I will be marking the things. So they said focal length is 10 centimeter. They have given this thing, and they have said like object is at a distance 9 centimeter. So they are asking what is the magnification produced. So what you can do, you know the object distance, you know the focal length. So what you can do, you can use lens formula and you can find what is the image distance. So 1 by v minus 1 by u equal to 1 by f you can use, and you can find the image distance, which is minus 90. The meaning of minus 90 is it is going to be on the same side at 90 centimeter, right? So it is going to be obviously virtual image. So image is going to form at a distance 90 centimeter. So what is the magnification? You can take similar triangles, or you know magnification will be v by u magnitude wise, right? So magnification you can get. Magnification is going to be 10. So till here we found. Now they are asking to find angular magnification. In the second question they are asking what is the angular magnification. Now the thing about angular magnification is how it is defined. Now let me say there is some object. Now the size of the object won't change whether I move it away or whether I move it closer, but I can see it much clearly when I move it closer. So what is the reason? Our eyes perception will be based on what is the angle subtended by it. Though its size doesn't change, if I move it far away, the angle subtended will be small. When I move it closer, the angle subtended will be more. So if the angle subtended is more, I can see it more clearly, but there is again a constraint. Now if I want to see it clearly, I'll keep moving it. Assume like I am normal human being where my near point view is that 25 centimeter. I can't see things clearly below 25 centimeter. You can visualize it that way. So if I want to see it clearly, I will start moving it closer so that the angle subtended will be more. But there is a restriction. What is the restriction? I can't move it below 25 centimeter. So this is the maximum angle subtended if I want to watch it with my naked eye, right? So what is the maximum angle subtended with my naked eye? Now this is the height of the object and this distance is 25, right? So this is the height of the object, this distance is 25. So what is the angle subtended? I can say the angle is small, so tan theta will be almost equal to theta. Theta is h naught by d. So this is the maximum angle subtended with my naked eye. Now I need to use some instrument and I need to make this angle more than this theta naught. But at the same time, we need to feel we are seeing something which is more than 25 centimeter, right? So we'll see how we can do that. If you see here, I placed the object at 9 centimeter. If lens was not there, I would have not been able to see it clearly. But because of the lens, what is happening? Image is forming at a distance 90 centimeter. Though I am seeing the rays which are coming from this object, I will feel those rays are coming as if they are coming from here. So I will feel the rays are coming from 90 centimeter, which I can see much better, right? So that is how we will be using this instrument, and we will call it as simple microscope, right? Now angular magnification. How to define angular magnification? Now old angle, maximum angle subtended in the earlier case is this much. Now we'll see what is the angle subtended in the new case. So this is the angle subtended in the new case. So how much is that angle? Again I can say alpha is h naught by 9 or h1 by h object and image. So h naught by 9 or hi by 90. So alpha is h naught by 9 or hi by 90. Now angular magnification is defined as new angle subtended by old angle subtended. New angle subtended by old angle subtended. New angle subtended is h naught by 9. Old angle subtended is h naught by d. D is 25 centimeter. H naught by 25. So you will be getting 29 by 5, which is almost equal to 2.8. And this is called as angular magnification or magnifying power. Is angular magnification equal to magnification? No. You can see it here. They are not equal. Now going to the next question. At what distance should the lens be held from the figure in order to view the squares distinctly with maximum possible magnifying power? So maximum possible magnifying power will happen when the image is forming at, okay, if you see this one, image is forming at 90. Now what I can do, I can move the object further closer, so the image will be formed further closer. So till where I can move it, so that I can increase the angle when the image is forming at 25. So maximum magnifying power will happen when the image is forming at 25 centimeter from our eye. So that's what we are going to use it here. So final image has to form at 25 centimeter, then we need to find magnification, we need to find magnifying power. We will be doing the same thing. So I'll be just rounding off what are the things given. Focal length is given and final image is given. Image has to form at 25 centimeter. Focal length is given. So I can use lens formula and I can get what is the object distance. So I can use the lens formula and I can get the object distance, right? So object distance, which is almost 7, but with my naked eye I would have not been able to see it. Even though I am putting at almost 7 centimeter, image is forming at 25 centimeter and I have increased the angle by a greater amount. We can see that. Now what was the angle, what was the maximum angle that can make with my naked eye? It is h0 by d, h0 by 25. Now what is the new angle subtended? Either h0 by 50 by 7 or h1 by 25, but I will be taking this one because h0 and h0 will be getting cancelled. So new angle subtended by old angle subtended, when you do that you will be getting 7 by 2, which is 3.5. Here also when you do the magnification you are getting 3.5. So in this particular case they are going to be equal. In this particular case, when the final image is formed at near point, that is 25 centimeter, magnification and angular magnification are going to be equal. Now going to the next question. So they are saying like a square of area. Okay, so earlier it was 1 millimeter square, now it has to show like 6.25. So you know the magnification. Area is becoming 6.25 times, so you can see like length will become 2.5 times. Yeah, so they said magnification is 2.5 times. Now again, I'll just round off the information what is given in the question. What is the information given in the question? They have given focal length, then and they were talking about magnification. They gave magnification is 2.5. Magnification is 2.5. Now, and I know this. I know object and image will be forming on the same side. So u is negative, v is negative. So v by u is going to be positive. So magnification is going to be positive. So v is negative of its magnitude, u is negative of its magnitude. So when I do that, I will be getting this relation. I will be getting this relation, and I will be using lens formula, and I will be using this relation. From there I can get u value as 6 and v value as 15. U value as 6 and v value as 15. So calculations you can do. I am just going with the core concept. So based on their magnification thing, I concluded like object has to be placed at a distance 6 centimeter and image will be formed at a distance 15 centimeter. But this is just a theoretical thing, because when the image is forming at 15 centimeter, we can't see it properly, right? And if you want to find, you can find the angular magnification also, but that doesn't make sense because we can't see it properly in the first place. Now, yeah, that's all about simple microscope. Now we will be going with compound microscope. A compound microscope consists of objective lens and of focal length 2 and eyepiece of focal length 6.25 separated by distance 15. How far the objective should be placed? Should an object be placed in order to obtain final image at 25 centimeter and at infinity? And what is the magnifying power of microscope in each case? Now again, this is the maximum angle that can be subtended with my naked eye. This is the reference. Now we need to see what is the new angle subtended, and we need to take the ratio with the old one, right? Now again, I will be just marking the things what all have been given in the question. They gave focal length of objective. They gave focal length of eyepiece and separated by distance 15 centimeter. They have given this distance also. So now I am seeing like where the object has to be placed so that the final image. Now if I keep the object here, this will act as object for this lens and image will be formed here. Now this will act as object for this lens and image will be formed here. Now final image has, my eye will be here. Final image has to be at a distance 25 centimeter from my eye. So I am going with the first case where they ask final image has to form at 25 centimeter. Now I know this focal length, I know this image distance. So I can use lens formula and I can find this object distance that you can see here. I know image distance, I know focal length, I can find the object distance. Now if I know this is 5, I know this total is 15, so this is going to be 10. Now if you see this lens, you know image distance, you know focal length, so you can find the object distance using this. You know image distance, you know focal length, you can get the object distance. Now once I get till here, I need to find alpha. What is alpha? Alpha is h1 by 5 or h2 by 25, h2 by 25. So alpha is either h1 by 5 or h2 by 25, h1 by 5 or h2 by 25, but I will be taking h1 by 5. Now what I need to do, I need to find angular magnification. Okay, anyway, angular magnification is going to be how much? Alpha by theta naught. Alpha by theta naught. Alpha is h1 by 5, theta naught is h0 by 25. Now when I do this, I will be getting h1 by h0 into d by 5. Now this entire thing is called as angular magnification. I don't know how to denote it, so I am just using my own symbol, whatever it is. So angular magnification, what is this? h1 by h0. If you see the figure, h1 by h0 is nothing but magnification because of this lens, right? Height of the image by height of the object. So sometimes people will call it as magnification due to objective lens and angular magnification due to eyepiece, right? Anyway, that doesn't matter for me. So h1 by h0 into d by 5. D is 25. That's okay. Now h1 by h0. How to get h1 by h0? Either you can use this triangle and this triangle are similar triangles, or magnification is v by u. You can use any of that. So you will be getting 10 by 2.5 into 25 by 5, which is 20. So what does it mean by angular magnification is 20? The angle subtended has become 20 times more than what it happens naturally, right? Now if you see from the first question onwards, angular magnification is 2.8. So the angle subtended with the instrument is 2.8 times more than with naked eye. In this case, it is 3.5. So the angle subtended with the eye is 3.5 times more than with naked eye. In the next one, yeah, we didn't do it. In this one, it is 20. Now let us see the same question if the final image is forming at infinity. If the final image has to form at infinity, and this is called as normal adjustment and near point adjustment. Normal adjustment means image is forming at infinity, near point means image is forming at 25 centimeter, that is near point. So what all things have been given in the question? Objective lens, focal length, eyepiece and the distance between them. Now they are saying this image is forming at infinity. If this image is forming at infinity, its object, its corresponding object is here. This must be in focal plane. So I can get this length easily, right? It must be in the focal plane, which is at a distance 6.25 centimeter. If this is 6.25, this is 15, so this is going to be 8.75. Now I know V, I know F, so I can use lens formula and I can get what is the object distance. So this is how I will be using lens formula. I know image distance, I know focal length, I can get the object distance. Now once we are done with this, we need to find alpha and we need to divide with theta naught, right? What is alpha? Alpha is h1 by 6.25. Alpha is h1 by 6.25. Now I need to find alpha by theta naught. So h1 by 6.25 by h0 by d, which is 25. So which is h1 by h0 into 25 by 6.5. Now again h1 by h0, how you can find? Either you can take similar triangles or you can say h1 by h0 is nothing but 8.75 by this thing. 8.75 by this thing into 25 by 6.25, which is 13.5. So what is the angle subtended? It is 13.5 times more than angle subtended with naked eye. It is 13.5 times more than angle subtended with the naked eye. Now which is more? This is 13.5. When the image is forming at infinity, angular magnification is 13.5. When the image is forming at 25 centimeter, that is near point, angular magnification is 20. So obviously you can see near point adjustment will give us more angular magnification, right? Now going to the next question, it is 9.12. A person with a near point 25 centimeter is using a compound microscope of objective focal length and eyepiece focal length when an object is placed at 9 mm objective in sharp focus. Sharp focus means final image is forming at 25 centimeter and our angular magnification is maximum. Calculate the magnifying power of the microscope. Magnifying power or angular magnification both mean same. Now we will draw the figure and we will see like what all things are given. So what all things are given? Final image has to form at 25 centimeter and focal length of objective is given, focal length of eyepiece is given, and an object is placed at a distance 9 mm. Now what I can do, I know object distance, I know focal length, so I can find the image distance using this way. I can find the image distance. Now for the second lens, I know focal length, I know image distance, so I can find what is the object distance, right? So now I know everything. I know pretty much like everything. Now what is alpha? Alpha will be h1 by this much or h2 by 25, right? So alpha will be h1 by 25 by 11 or h2 by 25. Now I need to find alpha by theta naught. h1 by 25 by 11 by h0 by 25, which is h1 by h0. Again h1 by h0, how you will be getting? Either you can take similar triangles or you can say it is 7.2 by 9. Again, be careful with centimeter and millimeter and stuff, right? So you will be getting 88. So what does it mean by 88? The new angle subtended. This particular instrument is making the angle subtended with my eye 88 times more than how it happens naturally, right? Yes. So the next one, an angular magnification or magnifying power is 30 times desired using objective of focal length 1.25 centimeter and eyepiece of focal length 5 centimeter. How will you set up the compound microscope? So there will be many ways. So let us see like how it looks in near point adjustment. Okay. So I will be just marking the things which all have been given in the question. So what all things have been given in the question? Focal length, objective focal length 1.25 centimeter is given in the question. Eyepiece focal length 5 centimeter is given in the question. And we are taking near point adjustment, so 25 centimeter. Final image has to form at 25 centimeter. Now, okay, and yeah, zoom, it is 30 times. So angle subtended alpha is 30 times of old thing. This is given in the question. Alpha is 30 times of theta naught. Alpha is 30 times of theta naught. Anyway, we will see that. Now what I can do is, for this lens, this will act as object and image is forming here, which is at a distance 25. So I know focal length, I know image distance, so I can find object distance. Now if you want how I found it, this way. So I found object distance, but there is a problem here. I know only focal length, I don't know image distance. I mean, this I found and I wrote it, but I don't know any of these two. But they have given some other information. What is the other information they have given? Alpha by theta naught is 30. Now let me see what is alpha naught. What is alpha? Alpha is h1 by 25 by 6. What is theta naught? h0 by 25. So h1 by 25 by 6 by h0 by 25. This is given 30 in the question. So when I do it, I will be getting h1 by h0 is 5. And what is h1 by h0? Now h1 by h0 is nothing but this distance by this distance ratio, right? Now this is image distance, this is object distance for objective. So I am calling this one as u0 and v0. So h1 by h0 is magnitude of v0 by magnitude of u0, sorry. Right? So now we know this thing. Apart from this, we can use lens formula and we can get what is the object distance and what is the image distance. So what is the object distance? We got 1.5 centimeter and image distance is 7.5 centimeter. So when we put the object at a distance 1.5 centimeter, we will be getting the final image at a distance 25 centimeter, that is near point adjustment, and the angular magnification is going to be 30 times, that is 30 times more than the angle subtended naturally, right? Okay, going to the next question. Now we are going to telescope. A small telescope has an objective lens of focal length 144 centimeter and eyepiece focal length 6 centimeter. What is the magnifying power of telescope? What is the separation between the objective and the eyepiece? So they didn't say which kind of adjustment it is, so we are going with normal adjustment. That is, image is forming at infinity. If image is forming at infinity. Now if telescope will be having objective lens and eyepiece. Now objective lens focal length is given in the question, eyepiece focal length is given in the question. Now what they said image is going to form at infinity. Now object also will be at very large distance, right? Object will also be at very large distance. That's what we will be doing using telescope, right? We will be observing things which are very far away. So if object is at very large distance, its corresponding image is going to form in the almost in the focal plane. So this image distance is going to be 144 centimeter. So whenever you have telescope, you can easily get this distance, which is going to be 144 centimeter. Now this is the object, and for this is the image. Now this will act as object for this lens, and image is going to form here. In normal adjustment, this will be forming at again very large distance, that is infinity almost, right? So if the image is forming at infinity, then its corresponding object must be in the focal plane, which is at 6 centimeter distance, right? So this is at very far distance, so this is going to be 144 centimeter. This image is forming at very far distance, so this distance is going to be 6 centimeter. Now if this lens was not there, if this thing was not there, if I was watching this object, what is the angle subtended with my eye? This is the angle subtended with my eye. If this system is not there, if I am observing this object, This is the angle subtended with my eye. Now what is the new angle subtended with my eye? This one. Now if this is theta naught, this is also going to be theta naught. Similar triangles you can see. So this is the new angle subtended with my eye. This is the old angle subtended with my eye. Now if I take the ratio, that is going to give me angular magnification, right? So alpha is how much? Alpha is h1 by 6. Theta naught is how much? h1 by 144. Theta naught is h1 by 144. Alpha is h1 by 6. So if I take the ratio, I will be getting 24. So using this instrument, what I did, I have increased the angle subtended with my eye to 24 times. 24 times the way how it works naturally, right? Now we'll see. Okay, I think that's all they are asking. Yeah. The next question: a giant refracting telescope at an observatory has an objective focal length and eyepiece. What is the angular magnification of the telescope? Okay, so again I am going with normal adjustment, that is final image is going to form at infinity. Object is at very far distance, so image will be forming in the focal plane. This focal length is 15 centimeter given in the question. This is given in the question. This is given in the question. So if the object is at very far distance, then the image will be forming in the focal plane, which is 15 meters. Meters, be careful, meters and centimeter. Now if this will act as object for this lens and image will be forming at very far distance, so if this image is at very far distance, then its object must be in the focal plane, which is 1 centimeter, right? Now what could have in the angle subtended with my eye by naked eye? It's like this theta naught, right? If this lens system is not there, the angle subtended will be this theta naught, which is this theta naught. What is theta naught? Theta naught is h1 by 15. Now this is going to be the angle subtended with my naked eye. I have converted everything into centimeter. Now what is alpha? Alpha is h1 by 1 centimeter, right? So if I take the ratio alpha by theta naught, I'll be getting 1500 times. So what I did, by using this instrument, I can magnify the angle subtended 1500 times. And what they are saying, they are asking one more question. It is, if this telescope is used to view the moon, what is the diameter of the image of the moon formed by objective lens, and diameter of the moon is 3.48. So in this particular figure, they have given this length. This length is 3.48 into 10 power 6, and this length is almost 3.8 into 10 power 8. That's given in the question, you can refer. Now what they are asking what is this distance. So you know this distance, you know this distance, you know this distance, you have to find this distance. You can use either theta naught, or you can use similar triangles property, and you can get it, right? So this distance by this distance is equal to this distance by this distance. When you do it, you'll be getting what is the height of the image formed because of objective lens. Going to the next question: a small telescope has an objective lens of focal length 140 centimeter and eyepiece 5 centimeter. What is the magnifying power? So normal adjustment and near point adjustment, both are there, so we'll see both of them. So what all things are given? Focal length of objective is given, eyepiece is given, and image is, we are doing for normal adjustment. The meaning is image is forming at very far distance. If the image is forming at very far distance, its corresponding object must be in focal plane, which is 5 centimeter. Now obviously you know this object is at very far distance, so its image is going to form in the focal plane of this one, which is 140 centimeter, right? So what must be the distance between the lens? We can adjust the lens, right? This is what we do, right? So what must be the distance between the lens? 145 centimeter for normal adjustment. So we'll see, anyway, we'll see angular magnification also. So what was the angle subtended with my naked eye? Theta naught, which is h1 by 140. Now new angle subtended is h1 by 5. So when I take the ratio, I'll be getting 140 by 5, which is 28. So new angle subtended is 28 times the old angle subtended with my naked eye. Now going with near point adjustment, again we know focal length of objective, we know focal length of eyepiece, and final image has to form at 25 centimeter. This is near point adjustment, right? Anyway, this object is at very far distance, so the image will be forming in the focal plane of this lens, which is 140 centimeter. This must be known, right? Now you can see for this lens, this will act as object, and this is the image. Image distance is 25 centimeter, object distance is object distance you don't know, focal length you know. You know focal length, you know image distance, you can find object distance, right? Using lens formula, you can get the object distance. Now what you need to see? You need to see what is the angle subtended with my naked eye. It is h1 by 140. What is the angle subtended using this instrument? h1 by 25 by 6. h1 by 25 by 6 by h1 by 140. When you do it, you will be getting 33.6. So using this instrument, I can increase the angle subtended by 33.6 times, right? Okay, in the next question, for the telescope described in the previous question, what must be the separation between the objective and the lens? That you can see in the previous question itself, it is 145, right, for normal adjustment. If this telescope is used to view a 100-meter tall tower, what is the height of the image formed by the objective lens? Then, yeah, what if it is near point adjustment and stuff. So we have done this, we have got this distance earlier also. So 145 centimeter. Now they have given this distance and they have given this distance. They asked what is this length. They have given this length and they have given this length. They asked this length. So either you can go with similar triangles and stuff, or I can say theta naught is almost equal to this length by this length. Theta naught is almost equal to this length by this length. So when you do it, you will be getting what is the image formed because of the objective lens, right? Now what they are asking, now this figure I have just copy pasted for normal adjustment, but in the third question they are asking about near point adjustment, so I will be using the near point adjustment figure. If this is the object, this is the image. Now it works the same way for normal or near point, but if this is acting as an object for this one, then this distance has to be 25 by 6 for the image to form at 25, that we have seen earlier also. Now, okay, now again in this case, if this object length is known and this distance is known, you can find this distance, right? So theta naught is this distance by this distance, theta naught is this distance by this distance. When you do that, you will be getting what is the height of the image, sorry, height of this one, right? Oh, you have to find the other height. So this one we have already done, this one we have already done. So we got this height. Now you can use similar triangles of this triangle and this big triangle, or you know for a lens, h1 by h2 is nothing but this distance by this distance. You can use magnification formula or you can use similar triangles, and you can see what is the height of the final image. What is the height of the final image? Okay, so the other kind of telescope you must be knowing, like we will be using 2 mirrors and stuff. Yeah, I mean, yeah, I think the figure is missing here anyway. So there are 2 mirrors, 20 mm apart. The radius of curvature of the bigger one is 220, the smaller mirror. So yeah, so we will see what is happening. So this is the kind of device. Now I will just mark the information given in the question. So what all things are given in the question? The mirrors are 20 mm apart. So I will be just marking the things which have been given in the question. This information is given in the question. The distance between this mirror and this mirror is going to be 20 mm. And the radius of curvature of large mirror is 220 mm and smaller mirror is 140 mm. Now you need to see where the final image of the object will be. Now object will be at very far distance obviously, so when the rays are coming parallel and hitting this mirror, those rays will try to converge at some point which is like focus, right? Now if this mirror was not there, then they would have focused there. Now let us see where they will be focusing. Focus is half of radius of curvature, right? So this distance is going to be how much? From here this distance is going to be 110, right? So I am going to mark it. So I understood this distance has to be 110. But what they said this is 20. So this is 20, this is 110, so this is going to be 90. This is going to be 90. Now you can see for this mirror, these are the incident rays. So this will act as object, right? Virtual object. So for this mirror, this is going to be acting as object. So we need to see where the image will be forming. So I can use mirror formula 1 by u plus 1 by v equal to 1 by f. Now you can see here incident ray direction is this way. So object distance is going to be positive, plus 90, and focal length is, again radius of curvature is also this side only, so focal length is also positive. So when you do that, you will be getting v is 315. Sorry, I think I did some mistake. Yeah, I think that's all. 315 mm from the small mirror, right? Yeah. Thank you.